Hi, welcome to my video on the addition formula for sine and cosine, number 5. And here I have some extra problems to do to finish off the addition formulas for sine and cos. Find the value of sine of theta plus beta if the sine of theta is negative 4/5 between pi less than theta. Theta is between pi and 3 pi over 2, and the cos of beta is 5 over 13 and is between 3 pi over 2 and beta is between 3 pi over 2 and 2 pi. Well, first of all, I like to deal with degrees, so pi is 180. 3 pi over 2 is 90, 3 times 90 is 270. 3 pi over 2 again is 270, and 2 pi, 2 times 180 is 360. So we want to find out what this addition formula is. So we can write down the addition formula. So the sine of theta plus b, the sine of theta plus b, the sine addition formula is sine cos sine, and we have theta and beta, and we have theta and beta, and the addition formula for sine doesn't change, so this plus stays as a plus. Now we need sine of theta, which is, we have the 4/5, but we don't have the cos. We have the cos of beta, which is 5 over 13. But we have the sine of theta, but we don't have the cos of theta. We have the cos of beta, but we don't have the sine. So that means we have to, what I'm going to do is go down here and draw a circle diagram. Now I'm dealing with the sine of theta is negative 4/5, and that's between 180 and 270. So theta is between 180, which is right here, and 270. So that means theta is somewhere in this quadrant in here. So we'll draw a terminal arm going out here, drop a perpendicular to the x-axis, and so this angle, whatever this, if it's 180 to 270, then theta stops here. So this is the reference angle. So I'm going to call that REF for reference. So the sine is opposite over hypotenuse, or it could be the y over the r. So this is the reference angle. So this is a negative 4. The hypotenuse is 5. So we need to work out what this side is here. So we have c squared equals a squared plus b squared, which is in this right triangle. And that's the same as r squared is x squared plus y squared. So this is the x that we don't have. So the r is 5 squared. The x we don't have, but the y is a negative 4. So that's a 25 equals x squared plus 16. And very quickly, x squared is 25 minus 16, which is 9. So that means x is plus or minus the root of 9. So x is plus or minus 3. So x comes out to be negative 3. So it's a negative 3. So that means that we have the sine. So the cos of theta is the adjacent over the hypotenuse, and the adjacent is the x, which is a negative 3 over the hypotenuse is 5. So the cos of theta is negative 3 over 5. Now we have to find what beta is, or the sine of beta. We have the cos of beta. So again, we draw another circle, rotation, and beta lies between 270 and 360. So it goes all the way around here. 180 is 90, 180, 270. Keep going. So it's somewhere in here. So this is beta, rotation. Drop it perpendicular to the x-axis. And I write down the cos of beta is 5/13. And cos is the adjacent over the hypotenuse. And so this is beta, so this is the reference angle. So cos is adjacent 5 over the hypotenuse of 13. So that means we have to find this side here to get the sine. So this is the y. Again, we have c squared is a squared plus b squared. So the hypotenuse is r, a is the x, and b is the y, or vice versa. So we have 13 squared. We have x is 5 squared, and we have to find a y. So it's 169, 25, y squared. So y squared, 169 minus 29 is 144. So that means that y is plus or minus the square root of 144. So that means that y is equal to plus or minus 12. And in this quadrant, y is going down, so y is negative, so that's a minus 12. So that means that the sine of beta, sine is opposite over hypotenuse. So here's a reference angle. Opposite is negative 12 over hypotenuse 13. So it's a negative 12 over 13. Now we can multiply these. What I found through practice is that if I cancel the 5's here, then I'll get a negative 4/13. But this denominator here and this denominator here, because I'm adding, I need the same denominator. So if we multiply these, I'll get a 20 over 65. Multiply these, I'll get 36 over 65. And the same denominator is 65. Add these up, I get 16 over 65, which is the value of sine of theta plus beta under these conditions. 16 over 65. Now I could have canceled the 5's here. I would have got a negative 4/13, but then I would have to go back and multiply this. If I had a negative 4/13 by reducing the 5's, I would have to go back and multiply by 5 again to get the same denominator. So I've learned by practicing these to leave the denominators alone in this case, because they become 5 times 13 and 5 times 13, they become the same denominators. Okay, that one's done. Let's look at another one, a little tiny bit different. Evaluate exact values. If I want the exact value, cos of the tan to the negative 1 of root 3 plus tan to the negative 1. So this is an inverse. So what I'm going to do is that I'm going to let alpha equal tan to the negative 1 root 3, and I'm going to let beta equal tan to the negative 1 on the negative 1 there. So I got the cos of alpha plus beta. And we have that done. So this cos becomes, cos form is cos, sine, alpha, beta, and the cos, in the addition formula for cos, this is a plus, so we make this a minus. Now, we have tan. So let's go and look at the tan to the negative 1 on the root 3. What we learned through previous videos on the trig number 2 videos, trig 2, is that tan is defined, the inverse of tan is between negative 90 and a 90. So from negative 90 up to a 90, the tan is negative number, and from 0 up to 90 is when the tan is positive. So if you pick up a calculator and do the inverse of tan of root 3, you will get this positive. You will get an angle between 0 and 90. So if you, just to explain it, I could use my calculator now and work out the inverse of root 3. And the inverse of root 3 is going to be, I can get an angle, but I can get an angle, but I don't need the angle, I just need what the cos the sine of that. So because this is positive, because that's positive, then the angle is between 0 and 90. So if I rotate up here so far and say, well, that's theta, turn my alarm, drop it perpendicular to the x-axis. So tan is opposite over adjacent. So in relation to this reference angle right here, opposite is root 3 and the adjacent is 1. So notice we have a 1 root 3, so the special right triangle, that's a 2. So that means that we have, this is, we made this theta, sorry, we made that alpha, so this is alpha. So the cos of alpha, cos is adjacent over the hypotenuse, so in relation to the reference angle is a half. The sine of alpha, sine is the opposite over hypotenuse, so opposite is root 3 over 2. So I can fit them in here. A half goes right here, and the sine of root 3 over 2 goes right here. Now we need to look at the tan is negative 1. And because it's negative, the angle is between 90 and 0. If it's positive, between 0 and 90. So let's draw the figure again. Circle. And it's between, if it's negative 1 is between 0 and negative 1. That means you have to have a negative angle. So that negative angle is rotating down here. You can't say that it's between 270 and 360. It's between 0 and negative 90. So here's the rotation. Draw the terminal arm. Drop it perpendicular to the x-axis. So this angle, this is beta. This is what beta equals to. So this is the rotation for beta right here, down to here. So this is the reference angle. And so notice we have a tan, again, is opposite over adjacent. Oops. So we have a negative 1 over 1. So in relation to this reference angle is, that's negative 1. The adjacent is 1. And so because we have 1 and negative 1, I recognize that these are, the angles here are 45s. So if I work this out, this hypotenuse becomes a root 2. 1 squared is 1, negative 1 squared is 1. Add 1 plus 1 is 2, and the square root is root 2. So we have the cos of beta. Cos is adjacent over the hypotenuse. Adjacent is 1 over root 2, and we multiply by root 2 over root 2. So it's root 2 over 2 when we rationalize. The sine of beta is opposite over hypotenuse, so that's a negative 1 over root 2, and that becomes negative root 2 over 2. So cos is root 2 over 2, and sine of beta is negative root 2 over 2. And we work that out, multiply. 1 times root 2 is root 2. 2 times 2 is 4. And we have a subtraction here. So this is a multiplication, so that's negative of root 3 times root 2 is root 6. And it's a negative. And 2 times 2 is 4. So that gives us root 2 over 4 plus root 6 over 4. When you subtract, double negative is positive, And the answer is root 2 plus root 6 over 4 as an exact value. As an exact value. Not if you use the calculator, you get an approximation. Now I could have come up with the angles. Again, this angle right here, because that's a 30, this angle is a 60. And that's a 30 and that's a 90. Because these two are equal with ones, that means that's a 45. So I could have had a 60 plus, again, when I say 45, but this is negative 45. So it could have been the cos of 60 minus this angle is 45. So I could have done it that way to get these answers, but I didn't need the angles because I just needed what the cos and sine in each quadrant was and fill it in. Okay, that brings us to the end of the addition formulas for sine and cos. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.